All right, so we're going to talk about how to come up with more irrational numbers. So we know a couple of rational numbers. For instance, pi, that's irrational, and that's approximately. When we do approximately, instead of using an equal sign, we use the squiggly equal sign. So pi is approximately 3.14159 dot 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 because it never repeats and it never ends. So one way to come up with another irrational number right away is to take the opposite of pi. So in order to take the opposite of something, you switch the sign to either negative if it started out as positive or vice versa. So here it's a positive pi, so we can come up with another irrational number by just making it negative pi. Negative pi is about negative 3.14159. So negative pi is negative 3.14 dot dot dot. Okay, so that's one way to come up with more irrational numbers. Another way to come up with more irrational numbers is, remember when we take the square root, of certain numbers, like a perfect square like 4, we get an integer as its square root. The square root of 9 would be 3, and so on and so forth. But if we're taking the square root of something between 4 and 9, we're not going to come out with a nice integer. We're going to come out with an irrational number. Okay, so if we did even square root of 16, these are perfect squares. 16 is a perfect square, so is 9, so is 4. Okay, but what if we did something between 9 and 16? Okay, let's say the square root of 10. Square root of 10 is not going to be a nice integer like this. It's going to be an irrational number. So whenever you're taking the square root of something that's not a perfect square, it's going to be irrational. So the square root of 10 we know is irrational because 10's just not a perfect square. If we type it into our calculator, again, I'm going to use these squiggly signs because this is an irrational number. We can't ever write it exactly because it goes on forever and never repeats. So it's approximately 3.16227, and it just goes on forever and never repeats. So a way that we could come up with another irrational number right off the bat is to take its opposite. So the way that we take the opposite of radical 10, since it's a positive number right now, we can put a negative sign in front of it. So negative radical 10 would be approximate to negative 3.16227 on forever. Okay? Another way that we could come up with more irrational numbers is if we started with an irrational number that we know, and then we multiply it by something. Let's say, so if I know that 1 times radical 10 is this, if I have 1 radical 10, and that's that, then if I take 2 of them, if I multiply 2 times radical 10, I'm going to get another irrational number, just twice as much. So I can figure that out. I'll take the square root of 10 and I'll multiply it by 2, and I will get something that is also irrational, and it'll be twice as much. So it'll be approximately 6.32455, and it just goes on forever. So 2 times radical 10 is also going to be an irrational number. I could also do 3 radical 10. I could multiply this radical 10 by 3, and it'd be somewhere on the order of 9, but it would be irrational. Okay? So that's another way to come up with more irrational numbers, starting from a base. Also, if you take an irrational number like pi, so pi is approximately 3.14159 dot dot dot. And if you square it, if you square pi, if I squared this, then I would come up with another irrational number. So I could square pi, which is irrational. I come up with another irrational number. So that's another way to come up with something that is irrational. How about this? Let's talk about cube roots. So cube roots are where we're not trying to think of two numbers that times each other, multiplied against each other equals the number inside here, but we want three numbers multiplied against each other to equal this. Three the same number. So what times itself 3 times equals 8? By the way, in order for me to designate, because this looks a lot like a square root right here, in order for me to designate that I want the cube root, I'm going to do this. I'm going to write a little 3 right there, right in this V. And that is showing me that I want to have the cube root of 8, not the square root. So the answer is 2. Because 2 times 2 times 2, let's see, 2 times 2 is 4, 4 times 2 is 8. So the cube root of 8 is 2. That's what a cube root is. We could take the cube root of another, so 8 is a perfect cube. We could take this, the cube root of 27. What times itself 3 times equals 27? Turns out to be 3. Because 3 times 3 is 9, 9 times 3 is 27. How about, what's the cube root of 64? What's the cube root of 64? What number times itself 3 times equals 64? 4. Because 4 times 4 is 16, and 16 times 4 is 64. Okay? So cube roots work nicely if they have this perfect cube inside it. Okay? Now, if you don't have a perfect cube inside it, you're going to come up with an irrational number. So here we came up with a nice integer. But if this is not a perfect cube, it's going to come up with an irrational number. So for instance, let's say the cube root of 45. If you type 45 into your calculator and you hit the cube root symbol, you will get this irrational number. Oh, by the way, I need to be putting this approximate squiggly sign because this is going to be an irrational number. So we'll say it's approximately 3.55689, and it goes on forever and never repeats. So this is the irrational cube root of 45. So you can come up with irrational numbers finding cubes of non-perfect cubes. I'm sorry, the cube roots of non-perfect cubes. Okay. Why don't I leave it there, and you can practice a little bit finding more of these irrational numbers given some of the basic irrational numbers that we have already been talking about.